Hey kids, so I want to compare finding the slope of a graph that you've been doing forever and finding the so-called slope or the steepness of a surface at a given point. And I'm hoping to convince you that they're kind of the same process. So let me go back to the graph for a second. Now in the graph, I want to find the slope at that point A. And I need a direction to kind of move from that point A, and it's usually expressed as a unit vector. And in a two-dimensional surface, the only unit vector we have is the vector 1, 0. So this is the direction I'm going to move. Now, I'm going to move in that direction, but I want to take a very, very, very small step, a very small step from A to another point. I'm going to move to the right. And so what I'm going to do is I'm going to go f of 3, and I'm going to take a very small step. So if you think of the limit definition of a derivative, I am going to go plus, I'm going to take the x coordinate of vector u. That's my step in the direction I'm going to go. And then I'm going to go minus f of 3. And my step size is just 1. And so my estimate for the derivative is -4. Now, if you recall the limit definition of the derivative, this x of u is kind of h, and this is also kind of h. So I could take a very, very small step if I wanted. So I could multiply that x coordinate of the u vector by 0.01, and I could divide by 0.01. And so the estimate for the slope of the curve at point A is around -3. And if you computed the derivative of f of x, which you know how to do, you could confirm that yourself. So we had a point on the graph. We had a direction vector, which was a unit vector that we were going to step or march off of point A. And then we went to another point, which is given by that function there. Now let's go back to the 3D version. So here's like my temperature profile, and there's my point P, and here's my function. And so I need a direction to move from that point, and the direction is not like, the direction is going to be given in terms of the xy plane. So it's going to be a unit vector, and I will choose the vector like that we've seen already. I'm going to choose 0.6, 0.8. All right? And it's hard to see because it's very, very small, but that little vector down there, that's the direction I'm going to move. So I'm going to move in a direction that is parallel to the xy plane. Just like in this example, I moved in a direction parallel to the x-axis, which is kind of where my domain is. So I have my direction, and what I'm going to do is I'm going to take a very small step away from point P to another point. We'll take a very, very small step. So I'm going to go t of, it's x of P plus the x coordinate of the u vector. And then it is y of P plus the y coordinate of the u vector. And then I'm going to subtract t of x of P, y of P. And right now my step is just 1. I'm going the entire unit vector, so my step right now is just 1. So that is an estimate of the steepness of the surface in that point. Now what I can do is I can take a smaller step. So instead of going an entire step in the x direction, I could go 0.01 there. I could go 0.01 there. And I could divide by 0.01. And so now my estimate of the steepness of the surface at that point is better. And if I took a smaller step, and a smaller step, and a smaller step. It probably changed way out here in these other decimal places, but it's kind of hard to see. So now that this is set up this way, we can change our vector to be any other unit vector we want. So I could change this to be 0.8 and 0.6 this way. And so now I go in a different direction. And it's kind of hard to tell if my direction changed. It did change. I took like a kind of a more of a turn to the x-axis, if you will. And it makes sense that it's like if I'm closer to the y-axis, I'm going to go up this curve here and it's going to be steep. But if I turn closer to the x-axis, I'm going to go along this curve, which is not as steep. So it seems like that should be a little bit smaller than the other one. And if I wanted to go in like a 45-degree angle, I could go SQRT of 2 divided by 2. And then I do the same thing here, SQRT 2 divided by 2. And that will move us in a 45-degree direction, kind of moving in that direction there. Okay, I think you should be set up now to do page 2 in the Exeter stuff. You should also make sure you take some time and complete anything that you did not complete on page 1. And take advantage of GeoGebra, guys. This is a good tool to use, especially for multivariable, because we'll learn how to do stuff, and if there's something you don't know how to do, let me know and I'll show you how to do it.